Okay, so this was our last example of binomial expansion using Pascal's triangle. And we can see here that to get the coefficients, we needed to know the sixth row of Pascal's triangle. Okay, to get that was 1, 5, 10, 10, 5, and 1. Okay, but there actually is another way of getting those numbers without doing out Pascal's triangle. So, if I can get rid of this photo, great. Here is our way of getting the certain rows in a binomial expansion. Okay, so if, for example, I had a power of 7 in my first question, then I would do 7 choose all the different things. Okay, so bear with me. If I hadn't come up with this first row, I just want to get rid of some of the chaos. Okay, this number 1 here. Okay, I can find what 1 should be by putting into my calculator 5 choose something. Okay, now it's what term this is, but not fully, because remember, in our last video with Pascal's triangle, we discussed how many terms there was in my final answer. Okay, in a binomial expansion, if it's a power of 5, that means there's 6 terms altogether. Okay, so I want to somehow allow each of these to be 5 choose something. Okay, 5 choose something. Now, we are going to be changing the number on the bottom as we go. Okay, but we are not going to start at 1, because if we started at 1, then by here we would get 6. Okay, if you type into your calculator 5 choose 6, your calculator is going to give you error. Okay, so where do we start? Just like in the powers, okay, we're including 0 when we're counting these. So it's 5 choose 0, 5 choose 1, 5 choose 2, 5 choose 3, 5 choose 4, 5 choose 5. Okay, if you type them into your calculator, on the older calculators, there's a button on top of the divide that looks like this, N, C, or. Okay, that's on the older calculators, and to press it, we just press Shift and then divide it. Okay, so it's on top of the divided, so we press Shift and then press the divide symbol. On the new calculator, it is a bit longer. You have to go into catalogue, then probability, then combination. Okay, then because you've gotten that C up, press the back arrow so that you can insert the 7 and then go forward so you can press 4. Okay, this is a lot longer to do, so make sure instead of just typing like this every time, that you are, after you get each answer, you are pressing the back button and just changing this 4 out for a different number. Okay, the key with this is, if you know the row from Pascal's triangle, if it's an early on row, don't waste your time doing out these, okay? But the key is that if it was a power of 7 or 8 or 9 here, okay, if let's say it was a power of 9, I'm not going to do out 10 rows of Pascal's triangle to see my different coefficients, okay? It's easier for me to go through this method using this idea of, if it was a power of 9, 9 choose 0, 9 choose 1, 9 choose 2. Okay, when we get halfway, they always start repeating on themselves. It's always mirroring each other. Okay, so you can continue doing them up until 5 choose 5 in this case. But then it's actually a nice opportunity for you to double check over your answers. If you've gotten all this grey line here that I'm going over, if you have all this written, it's a nice opportunity for you to just check, does that look right? Did it start mirroring back on itself? Okay, so that's all our binomial expansion really is. Okay, it's just learning these steps. So if we were to get rid of our Pascal's triangle, okay, and we just focused on our binomial expansion, other than the fact that we don't need Pascal's triangle, it's the exact same as what we were doing before. So if I was to give you something like, let's say a minus 2 b to the power of 8. Okay, it's the exact same as my Pascal's triangle. Okay, what I'm going to do is I'm going to find, well, what should be first on the line if I was to do it out like the same way I done Pascal's triangle. Okay, now I know it's going to start with the number 1, but still I'm just going to show you it's 8 choose 0. Okay, then I open up my 2 brackets after that. Okay, then plus 8 choose 1, 2 brackets after that. Plus 8 choose 2, 2 brackets after. 8 choose 3, 2 brackets after. Okay. 8 choose 4. So because it was a power of 8, I'm expecting there to be 9 terms. Okay. So. Okay, so hopefully I've done this. I've done it a bit too big, I think, at the start. I'm going to have to try and narrow up these. 8 choose 6. Okay, I'm going to have to do what I absolutely hate doing, which is go on to the next line. Whoa, what did I just do? Sorry, I was thinking in my head of the 9th term there. And I wrote down the number 9, which is completely incorrect. 8, choose 8. Okay. Right, so that was our first step. Second step, take the first term, put it as the first term in all of them. A. Okay, don't worry about powers or anything yet. Okay. And then second term, minus 2b. Minus 2b. Minus 2b. So into all of those second brackets, minus 2b, minus 2b, minus 2b. Okay, next thing I'm going to do, I'm going to get my powers. Okay, so I'm going to have to put powers on all the a's and powers on all the minus 2b's. So a's, I'm going to start here with 8, and I'm working down 6, 5, 4, 3, 2, 1, 0. Okay, and then here I'm going to start at 0. And work up to 8. 2, 3, 4, 5, 6, 7, and 8. Okay, so I now can get what the answers for my Pascal's triangle, that 9th row would be, by typing into my calculator, 8 choose 0. Okay, so that's going to give me the number 1. Okay, do I need to write 1? No. Okay, then I'm going to get a to the power of 8. Anything to the power of 0 is just 1, so it's a to the power of 8 by 1, which I don't need to write. Okay, next one. I'm going to write the plus here, okay, but if you type into your calculator 8 choose 1, okay, so you see that that is an 8 there, okay, then I have an a to the power of 7, and then I have a minus 2b to the power of 1, so a minus 2b to the power of 1, so the minus 1 is acting on the minus 2, and it's acting on the b. Okay, so I'm going to actually have to go through this again and multiply that 8 by the minus 2. Okay, then I'm on to this one. And I wrote the 6 in the wrong place. Apologies, I'm getting confused at how small my writing is here. Okay, so 8 choose 2 is 28. Okay, 28. Then I had my a to the power of 6. And then it's minus 2 squared. Okay, what's minus 2 squared? It's a plus 4. And then b squared. Okay, next one, 8 choose 3 is 56. Okay, my a to the power of 5. And then my b. Okay, so I have a minus 2 to the power of 3. So that's a minus 8. Okay, so it's a minus 2 by minus 2 gives me plus 4. By another minus 2 is minus 8. Okay, so remember the rule, if it's a negative and it has an even power, it becomes positive. If it's a negative and it has an odd power, it stays negative. Okay, and then my b to the power of 3. Okay, 8 choose 4 is 70. And then I have a to the power of 4. Okay, so now I have minus 2 to the power of 4, so it's an even power, which means the minus is going to become a plus. Okay, so it's 16, and then b to the power of 4. Okay, 8 to the power of 5 then, so is it going to start mirroring itself? Okay, so 56, yeah, look, that's what I got here. Okay, a to the power of 3. And then it's going to be a minus 32 by b to the power of 5. Okay, if I was stuck for time, I could jump straight without putting it into my calculator and say that the next one must be 28. Okay, a to the power of 2, so a squared, and then minus 2 to the power of 6. Okay, so it's an even power, so it's going to become positive, and then it's 64, and then b to the power of 6. Okay, 8 choose 7 is going to be the number 8. A to the power of 1 is just a, and then minus 2 to the power of 7 is what should be written there. Okay, so 64 by 2. Okay, but remember it's keeping its minus because it's an odd power, so it's minus 128. Okay, and my b is still to the power of 7. And then my last one, 8, choose 8. There's only one way to do that. Okay, a to the power of 0 is also 1. Okay, so 1 times 1, they're not going to affect my answers. And then minus 2 to the power of 8. Okay, so again, it's an even power, so it's going to give me a positive final answer. Okay, and it's by 256, b to the power of 8. Okay, so I'm going to go through this and do out my final bits of multiplication. Okay, all them things in orange I need to multiply what's in black. So, I'm going to get a to the power of 8 plus, and then I have 8 by a minus 2, so I shouldn't have done the plus. Okay, so it's minus 16, and then a to the power of 7, b. Okay, then I have 28 by 4 is 112, a to the power of 6, b to the power of 2. Okay, next one's going to be a minus 56 by 8, so 448, a to the power of 5, b to the power of 3. Okay, next one, 70 by 16 is, and remember it's all positives here. Okay, 1120, a to the power of 4, b to the power of 4. Okay, now we're here, 56 by minus 32, so 56 by 32, and it's a plus by minus, so I get a minus. Okay, 1792, and then a to the power of 3, b to the power of 5. Okay, next one is 28 by 64, so 1792, a squared b to the power 6. Okay, next one, 8 by minus 128 is minus 1024. A b to the power 7. Okay, and then next one, plus 2, 5, 6, b to the power of 8. Okay, so a few little checks here that I can do before I decide that I'm definitely finished this question. Okay, when there's a minus in here, check that it goes plus, minus, plus, minus, plus, minus, plus, minus, plus, or whatever, like minus, plus, minus, blah, 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 whatever way it is. But basically, if there is a minus in here, every second term is often a minus and then a plus. Okay, so if there's a pattern like that, look out for it. Okay, there's also another pattern that I can check for, and it's that all the powers in each of these always add up to that original power. So here I had an a to the power of 8 by itself, that's fine, it's 8, a 7 and a 1 on the power of b, so that's 8, 6 and 2 is 8, 5 and 3 is 8, 4 and 4 is 8, 3 and 5 is 8, 2 and 6 is 8, 1 and 7 is 8, and then an 8 by itself. Okay, so that's my final answer there for that one. That is a nice binomial expansion.